The Space Shuttle was an incredibly complicated vehicle. It took thousands of people working together to get it ready for launch into orbit. The launch sequence was equally complicated. There were hundreds of checkouts and procedures that had to be executed perfectly in order for the liftoff to occur. Believe it or not, the launch countdown actually started 43 hours before the scheduled launch time. We're going to pick up the countdown at the T-3 hours and holding mark. T-3 hours and holding. At several predetermined points during the launch countdown, NASA will pause the clock as part of a standard procedure to give the ground teams time to resolve any unexpected issues that may crop up. At the end of those built-in holds, the countdown clock resumes. The hold at T-3 hours typically lasted 2.5 hours. During this hold, the astronauts began putting on their pressure suits and getting ready for launch. After 2.5 hours, the countdown resumed and the astronauts performed their traditional walk to the astrovan that would ferry them to the launch pad. Closeout crew members assisted them in putting on their protective gear and entering the orbiter. Getting in their assigned seat was not an easy thing to do. Remember, the vehicle is stood on its end, so everything is turned 90 degrees. Specially trained closeout crew members help them lock down their seat belts and attach their pressure suit fittings. T-9 minutes and holding. At 9 minutes, the clock enters a 45-minute hold. At the end of this hold, the NASA test director performs a launch readiness poll of the shuttle launch team. If everyone is in agreement, the countdown resumes.
And attention on the net, this is the NTD performing the launch status checks. Verify ready to resume count and go for launch. OTC.
OTC is go.
TBC.
TBC is go.
PTC.
PTC is go.
LPS.
LPS is go.
Houston flight.
Houston flight is go.
Myla.
Myla's go.
STM.
STM is go.
Safety console.
Safety consoles go.
SPE.
SPE is go.
LRD.
LRD is go.
SRO.
SRO is go. You have range clear to launch.
I copy all, and launch director NTD.
Launch director.
Yes, sir, at this time, the launch team is ready to proceed.
And NTD launch director, you are clear to launch Atlantis.
Copy that, launch director.
The countdown clock will resume on my mark. 3, 2, 1, mark.
T-9 minutes. The ground launch sequencer, which is an automated program that controls all activity during the final portion of the countdown, assumes control.
T-9 minutes and counting.
TLS auto sequence has been initiated.
This program continues to monitor the vehicle's parameters and is able to halt the countdown if a problem is detected. T-7 minutes 24 seconds. The command is given to retract the orbital access arm.
Go for orbiter access arm retract.
Should there be an emergency requiring the crew to leave the orbiter, the arm can be repositioned in about 15 seconds. T-5 minutes. The commander of the shuttle is given the go to start the orbiter's auxiliary power units, or APUs.
TLS is go for orbiter APU start.
These produce pressure for the shuttle's hydraulic system. There are 3 separate onboard APUs located in the aft fuselage of the orbiter. T-3 minutes 30 seconds. The orbiter main engines perform a gimbal test, making sure they have full range of motion in order to steer the vehicle. Once the test is completed, they are placed in their launch position. T-2 minutes. The crew is given the command to close their visors and initiate O2 flow.
Flight crew OTC, close and lock your visors and initiate O2 flow.
That's in work.
Alright, you know the drill.
T-31 seconds. Barring any technical issues, the go command is given for auto sequence start.
TLS is go for auto sequence start.
This means that the ground launch sequencer is handing off primary control of the countdown to the orbiter's onboard computers. T-16 seconds. The sound suppression water system at the launch pad is activated to protect the shuttle and its payloads from strong acoustical energy during liftoff. Massive water tanks on the northeast side of the launch pad release tons of water into the Rainbird system. The peak flow rate is 900,000 gallons per minute. T-10 seconds. The hydrogen burn-off igniters are lit. Contrary to popular belief, these are not used to light the main engines. Instead, they are used to burn off any hydrogen that might be left over from the engine purge process. T-8 seconds. If all systems are good, authorization is given to start the orbiter's main engines. T-6.6 seconds. With precisely 6.6 seconds left in the countdown, each of the 3 main engines are ignited sequentially at 120 millisecond intervals. The thrust they produce causes the shuttle stack to lean forward and then spring back. This is called twang. At this point, all 3 of the orbiter's main engines are at 90% of maximum thrust. 50 times a second, a computer on each of the 3 main engines examines close to 30 critical parameters, including sensor function, fuel pressures, temperature, vibration, fuel flow rates, and power status. T-minus 0 seconds. If all parameters are within limits, the orbiter computer sends out the commands for pyrotechnics to ignite the SRBs, split the bolts holding the shuttle to the pad, and release the umbilical cord to the external tank. T+, 4 seconds. The orbiter's main engines are throttled up to 104% of maximum thrust. T+, 7 seconds. The orbiter initiates a program to roll the space shuttle through a simultaneous pitch and yaw adjustment.
Roger, roll, Endeavor.
This is done for several reasons, such as reducing vehicle stress and increasing vehicle performance. Early analysis showed that rolling to the heads-down attitude would reduce the aerodynamic loads and stresses on the vehicle. The added benefit of this was a 20% increase in payload capabilities, simplifying the trajectory for a possible return to launch site abort maneuver. The heads-down attitude gives the commander and pilot a view of the horizon for reference should they need to fly the shuttle back to the launch site. Improved radio transmission. The roll points the orbiter's communication antennas toward ground receivers. T+, 20 seconds. Approximately 20 to 30 seconds into the flight, the orbiter's main engines are throttled down to between 65 and 72% of maximum thrust. This reduces the aerodynamic stress on the vehicle. This part of the flight is referred to as max dynamic Q. During this time, the combination of the velocity of the vehicle and the air density puts the highest dynamic loads on the vehicle.
And the 3 main engines on Atlantis have now been throttled down to 72% of rated thrust as the orbiter prepares to pass through the area of maximum dynamic pressure on the vehicle in the lower atmosphere.
T+ 1 minute. The command is given for the orbiter to throttle up its main engines back to 104% of maximum thrust.
Atlantis, you are go and throttle up.
Copy, go, throttle up.
T+ 2 minutes. The solid rocket boosters exhaust their fuel and are jettisoned. From an altitude of 220,000 feet, they float back to Earth on parachutes and land in the ocean. There they are retrieved and towed back to Kennedy Space Center for inspection and refurbishment to be used again on a future launch. T+ 6 minutes. On earlier missions, the orbiter remained in a heads-down orientation to maintain communications with the tracking station in Bermuda. Beginning with STS-87, the orbiter rolled to a heads-up orientation for communication with the tracking and data relay satellite constellation. T+ 7 minutes 30 seconds. The orbiter's main engines are throttled back just enough to limit acceleration to 3 Gs. T+ 8 minutes 24 seconds. The orbiter main engines are throttled down to 67% of maximum thrust. T+ 8 minutes 30 seconds. Main engine cutoff, or MECO, occurs 8 minutes and 30 seconds into the mission. The external tank is then jettisoned. The crew took pictures and video of the ET while it fell away from the orbiter. NASA would inspect these to see if any foam had broken away during launch and possibly impacted the orbiter. The ET fell back towards Earth and burned up in the atmosphere. Early missions used 2 firings of the Orbital Maneuvering System, or OMS, to achieve orbit. The first firing raised the apogee, while the second circularized the orbit. Missions after STS-38 used the orbiter main engines to achieve optimal apogee, and used the OMS's engines to circularize the orbit.
The ohms burn starting in 5 seconds. About now. Here we go. There we go. Whoa! That's a real burn. It's a long burn. We can do that again. You're right. There it goes. Yeah, that's like a 1/10 of a G. Where's your other boot, by the way? It's tied off.
The Space Shuttle's orbit varied from 120 nautical miles to 335 nautical miles. On average, liftoff to orbit took the shuttle about 9 minutes. So that's how you get a shuttle from the ground into orbit. From there, the orbital crew performed science experiments, made spacewalks, repaired satellites, and even docked with the International Space Station. They usually stayed in orbit about 2 weeks before beginning the re-entry and landing process. Thanks so much for watching. If I've earned your subscription, I greatly appreciate it. If you would like to invest in my channel, I have a Patreon page linked below. We'll see you again soon.